So section 8.7. No, this is variation, and K is going to be the constant of variation. So direct variation the way you write direct variation, if y is directly varies as x, then you write y equals the constant of variation x. Now another way to write that is if you solve for the constant of variation, it's going to be y over x. Inverse variation is y constant of variation over x. And if you solve for the constant of variation there, you'll see that it's y times x. So you can either do the red or the black, whichever one you're more familiar with, or if you aren't, it's probably better to learn it in the black when you read a problem. Joint variation and so this would be z, constant of variation, and it's xy. So it's varying as, z is varying directly as x and directly as y, but x and y are kind of an inverse kind of thing. So then it's a combined variation. And this is probably fairly typical. You're going to have both. Here's a constant variation t over p. Notice it varies directly as t, b does, and inversely as p. Now, to give you an idea of direct variation, if I use this direct variation, if I say the constant of variation, if that is 8, and then I go y over x.
Is that a K?
K is constant of variation. Yeah, K. If y is 8, then x has to be 1. If y is 16, x has to be 2. If y is 32, x has to be 4. Now notice, see how it does? As this one increases, this increases. They're direct. One goes up, the other one goes up. That's direct variation. If you had inverse variation, and if we thought about it this way, if you had 8, the constant of variation, if that was 8, then what you could have is if y were 1, x would have to be 8. If y were 2, x would have to be 4 in order to multiply to 8. If y were 8, x would have to be 1. And you see what's happening is as the y decreases, y increases, excuse me, the x decreases. That's inverse. That's direct and inverse variation. So if we look at number 1, that. It says, which of the following represents direct variation? A, B, C, or D? A. A is direct. Y equals KX. What would you, this would be direct. What would you say B is? Y equals K over X. Inverse variation. Now, C would be neither. D would actually be this. Y would vary inversely as the square of X. That's what you'd say there. Inverse as square of X. So number 2, which of the following equation represents D varies directly as A? Directly. Which one of those is a direct variation? D varies directly as T. I think I said A. Is A a direct variation? Yeah. A is a direct variation. D equals 400 T. So what's the constant of variation in that particular problem? K is 400. Is there another one that's direct variation? D to T, what? C, right? D equals 25 T. And what's the constant of variation there? 25. Okay. Now what they're going to do is they're going to tell you how it varies. They're going to give you a set of data that you can find the constant of variation. Then they're going to give you another thing that says, now what happens? What are these values? So it says the income I of a computer analyst varies directly as the number of hours. So what would you put over here? K, and where would you put H? Direct variation. You divide or multiply? You'd multiply by the number of hours, right? So they're going to give you, it says if the analyst makes $672 when he works 8 hours, how much will the analyst earn by working 36 hours? So what you have to do is take this information, solve for K. So K is going to be 672 over 8, which is what? 84. Notice 84 is $84 an hour. That's what he gets, right? So now it says if he works 36 hours, the income, the constant of variation is 84, and he works 36 hours. So calculator problem, who has that one? 84 times 36. 3,000 what?
24.
So he's working full time, right? 36 hours would be full time. Most places. Making $3,000 a week.
Hey, well, we need to turn this one in.
But when I take problems on the test, 2 of these problems are going to be on the test.
I'm just curious.
Yeah. I'll take 2 of the odd problems off of this thing. They'll be on the test. It's the only word problems that will be on the test. No other word problems. Everything else is number problems.
This is for the hour.
Our exam, next Wednesday. Yeah. So if you miss both of them, you're automatically at a 90. Worth 10 points. 5 points per each. Okay, 6. The distance d a spring will stretch varies directly as the force. So d equals what? K, what am I going to do with the F? Multiply it or divide it?
Multiply it.
Multiply it, right? Now, it gives you some information by which you can find the constant of variation. It says, if a force of 6 pounds is required for the spring to move 3 inches, so 3 inches is K times 6, then the constant of variation is going to be what? 1 over 2, right? Every 2 pounds of force moves the thing 1 inch. It says what force is required to stretch the spring 4 inches. So now we can solve it. 4-inch stretch, constant variation is 1/2. What force is it going to take? So the force is going to be what? 8. Multiply both sides by 2 is 8 pounds. Eight says the period of a pendulum, that's it, or the time it takes the pendulum to make one complete swing. So the period varies directly as the square root of the length. So what am I going to put where? Direct variation, are we multiplying or dividing? And multiply by what? Square root of the length. It's multiplying because it's direct, and it's the square root of L. Now it's going to give the information so you calculate the constant of variation. If the period of the pendulum is 1.5, when the length is 2 feet, so it's the square root of 2. So the constant of variation is what? 1.5 over the square root of 2. Find the period when the length is 5 feet. So P is what we don't know. The constant of variation is 1.5 over the square root of 2. And then it says the length is 5 feet. Remember to take it as the square root of 5. So P is going to equal 1.5. Now, those square roots, we can put them all under a single square root. So then it's 1.5 times the square root of 2.5. Thought about something. So what is that? In the last class, I took 5 into 2 and got 1.5. Or 2 into 5. I just was remembering that. So what is that? What is 1.5 times the square root of 2.5? Anyone? No one has a calculator out? What?
I'll get it. $3.75.
So that's seconds, right? I made a mistake and nobody caught it. Sorry. The stopping distance S of a car varies directly as the square of its speed V. So the stopping distance, constant of variation, the square of the speed. So what are we going to do? Multiply divide times V squared, right? If the car traveling 30 miles per hour requires 63 feet to stop. So with that information, we can calculate the constant of variation. 63 equals K 30 squared. So the constant of variation is 63 over 30 squared. It says find the stopping distance, S. Constant variation is 63 over 30 squared when the car is traveling 55 miles an hour. So that's times 55, and don't forget to square it. So we can do 63 times, and we can do 55 over 30 and square that, because it's squared and squared. 5 is 11, 5 is 6. So 63 times the quantity 11 divided by 6 squared. I guess I'd put 11 over 6, push enter, then square it, and push 63. However you want to do it, just make sure that you bracket that 11 over 6. Make sure you bracket it. What'd you get? You're still doing?
I got 211.
How much?
211.75.
We go with that. So that's the P stopping distance. It sounds reasonable. You're going to go 63 feet when it's 30 miles an hour and 211 when it's 55. Probably right. 12 says the speed V of a gear varies inversely as the number of teeth. So the V varies. So inversely is where we're going to put the T times multiply, divided by, which divided by the teeth, right? It says a gear has 45 teeth. So 45 teeth. And it makes 24 revolutions. So my constant of proportionality is 24 times 45. Now it says what is the revolutions, so what is the velocity? Constant of proportionality is 24 times 45. When the teeth are 36, right? I think 12 goes into there twice. 3 times there, right? 3 times. That's 15. So this is 30. Notice fewer teeth, more revolutions, right? That makes sense to you? Fewer teeth, more revolutions. Okay. 14. The current I in a wire varies directly as the voltage. I, constant proportionality directly as voltage, we multiply or divide?
Multiply.
Multiply, and inversely as the resistance. So what do we do there? Divide.
Divide.
Yeah. If the current is 10 amps, constant proportionality, 110 volts, and the resistance is 11, then K equals 10 times 11 over 110. What's that? So, no, just think about it. That's 1, isn't it? 10 times 11 is 110.
Yeah.
Numerator is 110, denominator. Don't be too quick on the calculator. K is 1. Then it says, find the current, I, constant proportionality is 1, right? When the voltage is 180 and the resistance is 24. Doesn't really go evenly. So 6 into 35, like 7.5. What is that? 7.5. Oh. I don't know. Did I do it right? I thought it was 7.5. What is that? Did someone? It's 180 over 24.
It's 7.5.
7.5. Thought it was 7.5, but somehow my math is going awry. Erase that so we can look at it. Okay. Here's a little think problem. 16. In the inverse variation, y equals k over x. What is the effect on x if y doubles? Well, if you solve this thing for x, that's what x is. Now, if we think of this, if we take a problem and we double the y, what could you do with this thing to get k over y by itself? One half of k over y, right? But that thing right there is this, isn't it? 1/2 x. So if you double the y, you get half the x. Now, if you take this particular thing right here, solve it for k. In order for this to not change, if you go 2 times y, and to get k back, what do you have to do? X over 2, right? It's an inverse variation. However you want to think about it. It's the only way that k stays the same. (18) says A varies directly as B. So we write A equals what? K multiply or divide? Multiply, right? And inversely as C. So what would we do with the C?
Divide it.
Divide it. Now, It says C varies, so looks to me like what you want to do with that problem is get C by itself on the left-hand side. So in order to do that, we're going to have to divide both sides by A, right? And then multiply both sides by C. Now we have the equation C equals KB over A. Now look at the last part of that sentence. Then C varies blank as B. What is the green one saying? C and B are which kind of variation? Direct variation. Varies directly as B, and what as A? Inverse, right? So it's directly as B, inversely as A. 20. The length of a rectangle is held constant. The area of the rectangle varies what with width? So area is length times width, right? If the length is constant, then the length is a constant of variation. And how does the area and the width vary? Directly, right? So that's the extent of that. Now we're going to start 10-2. What you will notice is that 10-1, excuse me. 10-1 is actually just a bringing together of all the information in 7 and 8. So as we do 10-1, this today, Friday, and Monday, it's going to kind of be a review for 7 and 8. Now notice 10-1 at the top of the page, it says solving quadratic equations by factoring. That we've done, and by taking square roots. That we'll learn, and that's going to introduce us to another method of solving problems. So, a quadratic equation, standard form. Is A is some constant number, x squared. In other words, it's the numerical coefficient of x squared. B is the numerical coefficient of x. C is your constant term, equals 0. That's standard form. Notice in the algorithm I gave you, remember I said get 0 by itself on one side. Write it in descending order, leading term positive. That's real close to standard form. Now, a quadratic. Now, the first thing that we have to see is A cannot equal 0. And that's question number 1. Why can A not equal 0 if you're solving quadratic equations? Well, what would happen if A were equal to 0? What would happen to the first term? Ax squared. Would it still exist? Then what kind of an equation would you have? Would you have a quadratic? If ax squared wasn't there, what kind of an equation would you call that? What's left? You say a linear equation, right? You take ax squared out of there. Then you have bx plus c equals 0, and that is a linear, right? It's not a quadratic. So in order for it to be a quadratic, the numerical coefficient of your leading term, that x squared term, has to be something other than 0. So that is why that first one. That number 2 says What does the principle of zero product state? Well, in that algorithm, remember that what did we do after we had it completely factored? What did we do after we had it completely factored? When we had zero by itself on one side. We set each one of the factors equal to zero. That's a zero product principle. That's how you find the values that are solutions to your problem. So number 4. This says write the quadratic equation in standard form with the coefficient of x squared positive. So x squared equals 3x plus 1. So how are we going to do that? What are we going to do?
How do you move over x squared?
Okay, we're going to move everything to the side that has x squared on it, aren't we? Because we want to have the leading term to be positive. So we're going to move everything else to that side. Then we get, oops, I don't want to have a plus. Now, is that standard form with the leading numerical coefficient positive? Yeah. 6. So what are we going to do with this one to get it in standard form? Okay, move the 7 over. Now, a quadratic equation, does it always have to have 3 terms? No. It can have 2 terms, we just have one there. Can it have 1 term? What would happen if you had x squared equals 0? You could have that, couldn't it? So it can have 3, 2, or 1, but it has to have which term? The squared term, right? It has to have that squared term. 8 y squared plus 6y equals 0. Now, is that in standard form? What's the first thing we have to do? What does the algorithm say we have to do with that? What's the first thing you have to do with that particular problem? The algorithm says descending order leading term positive 0 by itself. Then it says common factor. Is there a common factor? Why is a common factor? If you don't do that common factor, you'll never get it factored. Because you see, that's the only, that makes it what? Is it completely factored? What do you have to factor out yet? Well, I factored the y out. Once I did the common factor, it's completely factored, isn't it?
Yeah.
So now what do? I use that 0 principle, don't I? And what do I do? Y equals 0 and y plus 6 equals 0. So y plus 6 means y has to be what? Now, what are my answers to the problem? Yeah, y equals 0 and y equals minus 6. Both of those are. P squared minus 81 equals 0. So is that 0 by itself, leading term positive, descending order? So it's in standard form. What's the next thing you want to look always for? Common factor. Is there a common factor? No common factor, right? It's a binomial. What do you look for under binomials? Sum of squares, difference of squares, sum of cubes, difference of cubes. So is this one of those four?
Yeah.
Yeah.
Which one?
Difference.
Difference of what?
Squares.
Yeah, because 81 is 9 squared, isn't it?
Mhm.
So really, this is what you have, right? Now, how does that factor?
Is it P plus 9 and P minus 9?
P plus 9 times P minus 9, right? Equals 0. Now what do you do?
Solve for 0.
Okay, set each one of those factors equal to 0. So P equals minus 9, 9. So once you go here, you could actually say what? P equals plus or minus 9, couldn't you? See how these are not all the same type as you go through. What you have to do is you have to figure out what it does or what applies, which factor. So that factoring algorithm is really useful. So is 0 by itself?
Yep.
Descending order, leading term positive, common factor, no common factor. It's a what? Binomial, trinomial. Trinomial is the special case. That -5 on the back end says you can't have a special case when that has to be positive. So then what is your method of factoring this thing? Trial and error? So it's going to be V and V with what? Plus and minus. Two numbers times itself is 5, whose difference is 4. Which way is the 5? Negative or positive?
Negative.
Which one? 5's got to be positive, don't it? 5 and 1, isn't it?
Yeah.
Opposite signs. So, and then the 5 is positive, right? And the 1's negative. Right? See, because the last term's 5 times minus 1 is minus 5, right? And the middle terms are plus 5 and minus 1, right?
Yeah.
Okay. B plus 5 equals 0. B minus 1 equals 0. B equals -5. So is that my answers? I think if you do these problems, although they aren't going to be tested on right now, they're a mixture of everything that you've learned. And you will have to be able to figure out, and you'll have to be able to use that algorithm. Because when I give you the test, I'm going to give you 2 off the first section, and that's going to be, common factor, and 2 off the second section is going to be, trial and error, and 2 off the third section is going to be special cases, and 2 off. So you're going to have to figure every one of those things, right? Which one is it? And this is all mixed up. Here's x squared plus 10x plus 25. 0 by itself. Descending order. Leading term positive. Common factor. No. Okay, it's a special case trinomial, isn't it? You recognize what? The 25 is a 5 squared, right? The x is an x squared, and the middle term is 2 times the first one that's squared times the last one, right? That's 10. That's a special case. And what is a special case? It's x what? Plus 5, right? And so what's our answer? X plus 5 equals 0. X equals minus 5, correct? Tell me this, if this term right here were a negative 10x, how would that be different?
Could be X plus 5 and X minus 1.
It'd be x minus 5, right? And then your answer would be x is equal to 5. It'd still be a special case, but it'd be the special case of x minus 5. (16) 4y squared plus 20y equals 0. So is it 0 by itself? Descending order? Leading term positive? Common factor?
4y.
4y comes out. Is it factored completely? Yep. See, if you miss that common factor, you will be impossible for you to factor. Then you just do what? 4y equals 0. Y plus 5 equals 0. So this says y equals 0. Y equals minus 5. So what are my answers? That one and that one, right?